Tak, ahoj všichni. Hello everyone. Thank you so much for coming today and for staying today to hear this talk that's called And Now You Understand Service Workers. Briefly about myself, my name is Artem and I'm a software engineer. I teach automated testing at Epic Web and I also work full-time on my open source projects, some of which you might know, like MSW. Have you ever heard about MSW before? Wow, that will be very pleasant for you. So MSW is an API mocking library that uses service workers. In fact, a funny fact is that MSW is exactly 66.66% a service worker. And I was very excited when I heard that I can talk about this awesome API at FrontCon, because service workers allow us to do so much on the web. They give us the means to do browser-side caching. They imbue our apps with offline capabilities, allow us to send push notifications to mobile devices, even schedule some things for later, like doing background fetch or background sync, and even mocking APIs, although please don't use them for mocking APIs if you really want to use MSW. But the overarching theme of all of these features is progressive enhancement. These things allow us to build progressive apps, which means that our web apps are not just web anymore, they can feel and behave like native apps, and that's awesome. And what's really great about the progressive part is that you don't have to fully commit to building PWA to benefit from everything that Service Worker gives you. So this is where in my talk I wanted to go heavy into theory, talking about Service Worker lifecycle, different events, how you can, I don't know, have some different oddities, how it gets installed and validated. But then I realized that would be a wrong way to approach this topic, because think about it this way, pretty much everybody in this room didn't know React at some point. So everybody here had their first React task, and then the second, and so forth. And so you eventually learned React. But how did that happen? One thing for certain, you didn't go to the docs and just study and memorize every existing page, every hook and class method, every behaviors and limitations and bugs as well. You didn't do any of that. That would be a time waste. So instead, you did something much smarter. You build stuff with React. Okay. And I think that it would be a great way for us to also explore the Service Worker API, because building things is one of the most natural and pleasant ways to learn new things. So how about we build a service worker right now on this stage together, and not just an illustrational service worker, but actually the one we can put in production and start benefiting from all of those features, all of that progressive enhancement. And as any software, we will build it in 3 steps. We're going to make our worker work, then we're going to make it good, and finally we're going to make it great, which sounds like a good plan. So let's start. And a good place to start is to realize that a service worker is a JavaScript file. So it's not something that comes pre-configured. You don't install it from NPM, although you can use some libraries like Workbox to help you write service workers. But this is still a file that you write and maintain. And if you think about how we interface with DOM APIs to build our web apps, well, we use things like document, window, fetch, WebSocket, right? And those things, those classes and functions, they don't appear out of thin air. They are part of the global context, global object. And in the same way, service workers have their own global object. It's a little different for security considerations, but there's still a lot of similarities there. For example, we can add a global event listener just by calling add event listener, and in this case, we're listening to the fetch event. This is an important event because the browser will dispatch it automatically whenever your app makes a request. And you are able to observe that request by accessing the event key over here and the property called request. This will be a fetch API request instance, which you all know and used before, like having method and body and so forth. But observing requests can be useful. It's not the main thing you should do with the workers, though. You want to handle the network. And to do this, you can call event.respondWith. And if you provide to this method a fetch API response, it will use that response to respond to requests. And even now, this 3-line service worker is a valid functional worker. It will intercept every request our app makes and respond with this mock response hello frontcon and break our app. Because when we will be fetching CSS and HTML and JavaScript, we want to receive actual content, not hello frontcon. So how about we improve it a bit? Instead of handling all requests, let's handle a subset of requests. So just by adding this simple if statement, we can say, please only handle the requests which URL ends with /greeting. And this can be a request to our own API, to a third party, to a CDN maybe, it doesn't matter. So as long as it matches, it will receive this mocked response. Now, the mocked part is not very practical. We want to do more. Ideally, we want to use cache to respond to requests with cached responses. So how do we do it? We replace this response instance with immediately invoked function expression, basically to help us handle async await easier. And step by step, what we're going to do is use the caches object. It's another global object. use the open method and open a new cache by this key called cache. Very simple. And get the cache object back so we can put things in the cache, retrieve them from the cache, invalidate it, and so forth. Then next we're going to use cache.match and provide the reference to the request that we just intercepted. And by doing that, we're asking the worker, do you have any cached response for this request? And then we're going to use that cached response to respond. Even at this stage, you might notice an issue with this worker, actually two issues. First of all, what if the cached response is undefined? So we can't really respond with undefined. That would be an error. And the second bigger issue is that how do we even put responses in the cache, right? As Libor has mentioned in his talk, the service worker API is quite low level. And it's nice because we can do things like this. So here we're opening this cache, finding the cache hit. If it exists, we're going to use it to respond to request. And if it doesn't, we're going to use the fetch function, the same function you already use in the DOM, to perform this request and get the original response. If that response is successful, so it's not a 500 or a network error, we're going to put it in the cache using cache.put. We're going to use the request, the whole reference, as the key, and we're going to use the response as the value. And we're going to clone that response string to make sure that we can keep it in the cache and also use it to send it to the client, because we're going to respond with the original response. And now the only thing that I would change is this line, because this is pretty much a hard-coded value. We can do better. What if we try to capture all requests that are images, for example? So we can check if request destination is image, which means our application is fetching an image. Then we do all of this logic. We try to find if there's a cached version of the image, serve it. If there isn't one, let's fetch it, put it in the cache, and respond with the original. And even in these 20 lines of code, we implemented what is effectively cache-first, network fallback caching strategy. Very simple. So this service worker file is just JavaScript, right? It's not going to start handling requests magically for no reason. We need to tell the browser that, hey, I want to use this file as a worker. We do that by calling navigator.serviceworker.register and providing it the path to the worker, so sw.js in this case. And by doing this, the browser will register it in the background and the worker will start running alongside our app and handle images in this case. There are a couple of things to keep in mind when registering workers. You have to serve the worker script, that file that you wrote. It has to come from your app because, once again, security. You don't want some third-party app intercepting all your network traffic. That would be terrible. So you have to serve that worker from the app, for example, by putting it in the public directory or just procuring it by any other means. And the second thing to keep in mind is that the registration that you get, although you receive a promise, it doesn't actually mean that when it resolves, the worker is already functional and handling requests. It simply means that it has registered. Just keep that in mind. So, but what does it all do in practice? Surely a small 20-line of code service worker cannot provide any benefit, right? Wrong. Even this small service worker can increase the page load time tremendously. In fact, 6 times faster. I did a little benchmark on the app that you'll be able to explore yourself, and it's a very simple app that has a bunch of images. And what ends up happening is that when I'm on fast 4G on my phone, it takes 5 seconds to load this app, which is horrendous. Because over the network, we're trying to transfer almost 4 megabytes of images. But if we have the service worker, we are able to reduce the page load time to 750 milliseconds just by caching images alone. And the best part here is that we're no longer even using the network bandwidth at all. We have 0 megabyte network, because when you respond from cache, from the service worker, you don't create a network request. So there is no network round trip at all. And I think that works. Now let's make this service worker good. The first thing we're going to talk about is this predicate again. So we can handle images, which is very nice, but our apps need more than just images, right? We load a bunch of resources, JavaScript, CSS, and so forth. So how about we expand this condition to include images and fonts and styles and also scripts. And suddenly, just by making this small change, we apply this caching logic to everything, to basically all our static assets. And because we do, it would be nice to change this line. So we no longer open just the cache name cache, which is obvious but not very practical. Let's create a variable that is called assets cache name. And we're going to call it assets v1. And you can spot that we're trying to introduce versioning here. You will see why it's important a bit later. And then open that cache using the variable. So the next thing we can do to improve this worker is, well, we know for a fact that our application is going to fetch some JavaScript, some CSS, some HTML, so we can pre-open the cache for our assets. If we add the listener to the install event, when the new worker is getting installed, we can schedule this task with event.waitUntil and open this assets cache preemptively. So when the fetch happens, the cache will already be ready to handle this request, and that will be a much faster response. So the next thing to talk about is What about offline? So offline can be tricky, but let's see how we can implement offline support in the worker. Let's collapse this all. It still applies, but we're going to focus on a different thing. On this thing, don't be afraid, line by line, we're introducing a new cache, for pages in this case, pages v1. And we're also opening it preemptively in the install event, so it's ready. Now in the fetch listener, we can check what if the request mode was navigate, which means that we're navigating from one page to another page. And that if that's the case, we're going to handle these requests a little differently. We're going to fetch them first, which means get the original response, and then if that response is okay, we're going to cache it and respond with the original. And if fetching failed, only then we will serve content from cache. And what this means is that we introduce network first and cache fallback strategy. So serve this navigation request from original resource, and then if it fails, which means the client is having connectivity issues, or maybe is entirely offline, only then respond from cache. In practice, this means that the users that visit your app while offline will no longer see the dinosaur. They will see an actual functional app, which is nice. And like Danny mentioned, it doesn't mean that your app should do absolutely everything it does when it has network, but you should ship this experience that basically prevents this, oh shit, moment when the users go offline and your app is completely broken. You can also use advanced features like background sync and fetch to even schedule things for later so the users can interact with the app while offline. And that is all very good. But there are still a few things that this worker doesn't do properly. So let's make it great. So one thing, we introduced this cache, and we introduced versioned cache. The reason for that is that we would love to invalidate any old cache we have when a new worker registers, because we don't need it anymore. So we can add an activate listener, which means that this worker is active and ready to handle requests. And we can do a new task, event.waitUntil, and clear the old cache. So how would this function work? What we will do here is use the caches API again, this time calling the keys method. This will return us the array of strings, which are the keys to cache names. We can go through every key, and if that key is not in the new cache, the v2 in this case, the one that we need right now, we're just going to delete that key. And basically by doing this, we're invalidating any old cache our apps might have had from previous workers. Another thing is, if we talk about the offline support, so the user can visit our page, and that version of the page will get cached, so if they lose network, they will see at least the cached version. But what happens if the user is offline and they visit a page they never visited before? It's a dinosaur, again. What we can do instead is use pre-caching. We can basically tell service worker to take certain assets, in this case just URLs like about and blog, contacts, and put them in the cache. So when the worker activates, let's open the pages cache, because all of those resources are pages, and let's use cache.addAll to add them preemptively there. And what this is going to do is that when this worker is active, it's going to fire these requests in the background, so not to block your main thread, and fetch those resources and put them in cache. And we can handle these pre-cached resources a little bit differently. We can check, hey, if this resource is a pre-cached resource, we can check it if it exists in cache, which we'll probably will. If it's there, we will respond with a cached response, but notice that first we're going to do something different. We're going to have another wait until and fetch this resource for real, the original response. And then if it's okay, update the cache. And then of course, just in case the cache is not there, respond with the original. And by doing this, we effectively implemented stale while revalidate caching strategy. So fetch the original thing and update the cache. And that makes the worker great. There's, of course, more you can do with workers, but this is already a good MVP that brings value and works for your app. And one thing I want to talk about now, which is equally as important, is service worker horrors. Things that developers fear and dread about working with service workers. And I get it, there's been a lot of stigma throughout the years. Workers can be tricky to get right. And I would love to demystify some of the things and some of the problems that developers have. Starting with a very simple thing, local development. So where does the service worker fit when you develop your app locally? Because if you register it, it will start intercepting requests and potentially serving cached responses, and this may confuse you when you develop, and this will be just weird. And there's some advice online, like you can use a private window to develop your app, but that's not a good solution. That hurts your developer experience, because what if you want to use your extensions? What if you want to keep the sessions? I don't think that's a solution at all. And instead, I would just recommend not using service worker in development, because you're not writing it for yourself to help you develop. You're writing it for your user in production, so you can add an if statement and register the worker only for production use cases. But that doesn't mean going blindly. You should still test your worker. Like any software, you need to make sure that it works. Like here is an example of a playwright test that goes offline and then goes to the /products page, in this case on staging environment, and makes sure that there is a content being served. It's not just network error. The service worker is actually working and delivering results, whether it's cache results or whatever. So you have to have automation to make sure that you're not deploying service workers blindly. Another common fear is serving stale content. While I was preparing to this talk, I was tweeting about things I like about service workers, and one of my followers responded and said, hey, I love service workers, but I visited our client's website, and it turns out that the service worker there is serving content that's 5 years old. That's not very good. But the good part is that you can solve this problem by choosing proper caching strategies. And that's not difficult to do. It's not rocket science. In this talk alone, we already implemented 3 common caching strategies. So let's recap. You can use cache first and network fallback for static assets, especially if they're versioned, which means that there's a content-dependent hash as a part of the file name. So whenever you change your CSS or change your JavaScript, it will produce a new file name, and so you're not risking the conflict of namespaces when you look it up from cache. You can use network first and cache fallback strategy for dynamic but offline-friendly content. So serve fresh first, but cache for later in case connectivity issues, for example. And then finally, we can use stale while revalidate for pre-cached assets, the last thing we did. And by choosing the right strategy, you can save yourself from those issues, because probably the issue that the person experienced was that they cached the original response and then responded from cache all the time. And obviously this is not going to work. This will lead to stale content. And another thing to do is invalidate old cache. And this is something we already went through. It's just a reminder. So when the worker activates, delete the old cache so you never serve out-of-date content again. And the biggest fear that everybody has is, what if I mess it up? What if I make a mistake in my worker and now it breaks my app? Because workers can intercept network, and this means that if something goes wrong, your entire app has a chance to just fail. If JavaScript couldn't load or HTML, and that's not a good situation. And you need to fix it. And you are the best person who knows what went wrong, because you wrote that worker. That's not a very practical advice, though. So while you're fixing it, it will be great if your users wouldn't have to pay with their experience while you're figuring it out. So what you should do is deploy a kill switch, which is a literal worker, this on the screen, that will invalidate any faulty worker. It will just kill it, as the name suggests. And it will do so because it's a little special. It will tell the browser to skip waiting, which means install me right now. I just need to be installed as soon as possible. And when I activate, invalidate the old cache and unregister myself, because that's what the workers can also do. And by deploying this kill switch instead of a faulty worker, you'll be able to quickly act and prevent any regressions, any loss of revenue, and project managers being mad. A few things to consider is that you have to replace the faulty worker. So if sw.js was broken, it is the kill switch that also has to have name sw.js. So the browser will see, aha, there is a new content for the worker, I need to replace it. You cannot implement a kill switch on the client. As much as I would love to tell, like, you can use navigator.get all registrations and then just unregister all the workers. What if your JavaScript that does all of that is cached by the faulty worker? That's not going to work. And finally, you cannot refresh control clients. One thing I often see online is that the worker can refresh the pages and controls. So how about our kill switch registers itself and refreshes all the pages so people get the fix faster? But consider this. We're registering the kill switch, it kills the old worker. Now it forces the page to reload, which loads JavaScript, which registers the kill switch, which asks the page to reload, which loads JavaScript. So you see the problem here. We fixed one problem, and we're introducing another, the infinite load issue. So don't do that, and instead just unregister the worker for good. And of course, if those situations happen, you have to react fast. And automation is once again to the rescue. You can write smoke tests, specifically to run them against production or staging, to run them periodically. So it's not something that happens when you push a new commit or create a new PR. This is something that runs every hour, 2, 6, 24, to monitor the health of your system constantly. The point here is to run a subset of tests. So you don't have to run your entire 200 playwright tests taking half an hour. That would defeat the point here. You need to run only the critical paths. Does my homepage load? Can the user go through this very simple checkout flow? Or can they submit a contacts page? This kind of things. Because the point for this test is to be reactive and responsive, to give you feedback fast if something is broken. So I also recommend configuring some automation, maybe with Slack or Teams or Discord. So if such test fails, it can post and notify respective people from different teams so they can react fast, for example, by deploying a kill switch. everything I talked about in the worker we built today, you can find on GitHub. It's on ketanito/sw-demo. You can use it for inspiration and for reference. You can run that app on your machine, tweak it, see how it works with offline, pre-caching, and so forth. I think you will enjoy that. And if you want to explore service workers in more detail, I definitely recommend checking out this resource called serviceworkies.com. It is a game. It's an interactive game that will help you learn different concepts of service workers. It used to be paid, but now it's free, which is awesome, so definitely check it out. It will teach you a lot of things. Speaking about teaching a lot of things, I also recommend checking out the Epic Testing Bundle. This is something I work on Epic Web, and this is a series of workshops dedicated to automated testing. Right now it has 4 workshops and 90 exercises where you will be going through different problems hands-on, so it's not a course, you just watch passively. You will solve those problems and understand what the testing is about. And we cover a lot of things like what should you test and why, what is a good test actually, and how do you know when you write one. Also how to go and use different mocking techniques. Do you even need mocking and what it does to your code. Then we talk about how to test your React components in the actual browser, not in GSDOM. We're using Vita's browser mode and the results are great. And then also teaches you how to profile your slow tests and then improve their performance, sometimes by times faster. And a lot of other things as well. And since it's my first time speaking in Czech Republic, I wanted to do something interesting for all of you. I'm giving everybody in this room 70% off for today and tomorrow on these resources. So if you ever wanted to improve in automated testing to become the testing guy or girl on your team or company, there's no better way to do this. And I can say this confidently because I researched the entire web when preparing this to make sure that I address different misconceptions, old practices, and make sure that testing just clicks. So definitely check it out. Now there's one more thing before I go, and it's not related to service workers. I just wanted to tell a personal story. When I first started in IT many years ago, I started at a Czech design agency, I think not unlike the ones many of you here are working at, and I didn't know anything, really. So it was my first job, and I was learning JavaScript and React, and I was very excited. I was very eager to solve problems, like very eager. I was looking through code base, and like if I find 2 functions that are the same, I would abstract them, or even better, I would publish them to NPM, because what if somebody else needs this function? We would get a project with like 3 static pages and a .NET server. Say no more. There's this thing called Webpack. The version 2.0 was coming out, and the team is going to love it. It's not going to be confusing at all. So yeah, I did a lot of exploration, and I did a lot of problem solving and solutions, and I published all of those like findings and things online on GitHub because that's just the right thing to do. And over the years, I accumulated a ton of these silly ideas until I came upon an idea that was actually silly enough to work, which is MSW. It uses service workers to intercept requests and then handle them with mocked responses. And I was so excited about this concept. It was pretty new at the time, so I spent a weekend building a proof of concept, hacked it up. It was pretty rough, but it worked. And I was happy, but only when I pushed it to GitHub, something truly incredible happened. Nothing. Nothing happened for months. And of course not. So very nice idea, very nice concept. I shelved it. It gathers dust. Very good me. Until one day I wake up to this conversation, which doesn't load because I need an internet. So I went to Wi-Fi settings. And I chose that Wi-Fi. I don't know how I knew it back then. Yes, so I wake up to this conversation. So I'm waking up to this conversation from Ken C. Dodds, who's asking, who was building his Epic React at the time. And he was asking Twitter if there's a kind of library that can allow him to build backends in a service worker. That's a pretty interesting question. So he was looking for this solution because in his course he wanted to mock APIs. And back in the day, if you mock an API, you would replace the fetch function or XHR function or WebSocket. And that meant that requests would not really happen. You would just pretend that they did. But when he showed that to his students, they were confused because they would open the network and the DevTools, they would expect a request there, and it's empty because it never happened. And that's something that usage service workers solved. So my colleague at the time, Ruhais, tweets at him and asks, hey, does this MSW thing work for you? And he said, yes, it looks awesome. It wasn't awesome. It was very rough and it was very hacky, but Kent saw some progress in it, some kind of promised that this idea might work, so he opened the first issue, then the second, the 10th, and years later, MSW became de facto standard of API mocking in JavaScript. And turned out it didn't just solve Kent's problem, it solved everybody's problem. And now everyone is using MSW, from small startups, big ones, corporations, government institutions, healthcare, banks, everybody. Amazon, Google, everybody on this slide and many more. I'm extremely happy and privileged and honored to be in this position and to help people use proper testing practices through API mocking to build and test better software. And if there's one thing that I would like for you to take away from this talk, apart from service workers being awesome, of course, is this. Sometimes it can be very easy to get stuck in a rut, to feel like everything exciting on the web is happening somewhere else, not here. And I know this because I felt this way, especially when I started. But what I would love to encourage you is to challenge that feeling, to challenge the status quo, and to pursue the impossible, to reinvent the wheel, to do the ungrateful task, the one that nobody wants to do on the team, but everybody knows that we'll be better off if we did it. And while you're doing that, publish your discoveries and your ideas and your solutions on the internet, on GitHub, anywhere. Put those ideas out for people to see, no matter how silly you think they are. Because you never know when your silly idea might become a solution to somebody else's problem. Thank you.